Okay, guys, in this particular video, we're talking about the line segment relationships between tangent lines, tangent and secant lines, secant and secant lines, and that's what we're going to talk about. So the first theorem we're going to talk about is the tangent-secant theorem, and let's just review what that vocabulary means. The blue line segment from C to E is a tangent segment, meaning it's only touching the circle in that point E. And then the secant segment is the line segment that's both purple and red. Notice that I denote the outside part of the secant segment with the purple O, and I denote the inside part of the secant segment with the red I. And so the relationship between any tangent and secant segment that starts at one point and intersects the same circle is this right here. The tangent squared equals O plus I, and what O plus I represents is the entire secant segment times the outside piece. So the tangent secant theorem works like this. You're squaring the tangent part, and it's equal to the product of the entire secant segment times its outside piece. Hence, the O plus I times the O. On this particular picture, we have two secant lines that start at point C, and then they intersect the circle. And the secant-secant theorem works kind of like the tangent-tangent theorem or the tangent-secant theorem, but you don't square anything, okay? And so your relationship here is that you the relationship here is that you have the outside, the entire secant segment times its outside piece equal to the entire secant segment times its outside piece. So that's how the secant-secant theorem works. The tangent-tangent theorem is a pretty easy one. That's a relationship you've used on a lot of different other types of examples. This is your standard blank equals blank. But whenever you have two tangent segments that intersect a circle, but they start at the same point, that's just a blank equals blank relationship. And you're going to see different types of problems dealing with that as far as that's concerned. And then finally, we have what is the chord product theorem. This is another not too terribly hard relationship to understand. On the chord product theorem, you can see that this blue chord and this red chord were each split into two pieces. The blue chord is A and B. The red chord is C and D. But the relationship, the way you would figure out either A, B, C, or D, whatever you would need, is you would use this relationship here. A times B equals C times D. And if you need to go back and just review the equations just to make sure you understand them, do so, because in the next couple of slides, what we're going to do is we are just going to make sure you've remembered what the equations were. So we're going to go back to the tangent-secant theorem. That's what we talked about at the beginning. Which of the four equations that I've given you correctly describe the relationship between the tangents and the pieces of the secant segment? All right, which of the relationships here show the, which of the equations show the relationship between the two secant segments? All right, what is the relationship between the two tangent segments A and B? And what is the relationship between A, B, C, and D?